So yesterday, hopefully you saw it or you're going to go see it sometime today, the notes that I put up yesterday and the assignment. We talked about solving quadratic equations part 1. And yesterday we talked about solving quadratic equations using square roots and by factoring. That's what our bell work was about. Today we're going to solve quadratic equations by graphing. So before we can get into that, we need to first talk about how to graph a quadratic equation. Sorry, this is really small. If you can't read it really well, just try to pay attention up here the best as possible and go look at the notes later on. I'll try to explain things as we go. I've tried to zoom in, but it doesn't zoom in on the smartboard. So if I have, excuse me, golly. If I have a quadratic equation in standard form is f of x equals ax squared plus bx plus c. That's my quadratic equation in standard form. The two little graphs here, it's just showing two examples of a parabola opening upwards and a parabola opening downwards. If you look at this first point right here, it says the parabola opens up when a is greater than 0 and opens down when a is less than 0. So what that is essentially saying is if the number in front of my x squared term is positive, my parabola is going to open upwards. If the number in front of my x squared term is negative, it's going to open downwards, which we kind of saw that already when we did transformations, correct? If it had a negative in front of it, it was open downwards. If it was positive, it opens upwards. Also, we also saw this with transformations. The graph is narrower than the graph of our parent function. Remember, our parent function is f of x equals x squared. When the absolute value of my a value is greater than 1. So if my a value, the number in front of x squared, is some whole number, it's going to be narrower than the graph of my parent function. And then it's going to be wider than my parent function if it's a fraction. So if it's less than 1, between 0 and 1. So a whole number, it's going to be wider. A fraction, nope. Whole number, it's going to be narrower. Fraction, it's going to be wider. If you look at these red lines going through the middle of the parabolas, those are what we call the axis of symmetry. Everyone knows what symmetry means, right? What a symmetrical figure is. It's the same on both sides, right? So, with parabolas, we have this thing called the axis of symmetry because parabolas are symmetrical figures. That means all the points on the right-hand side of the parabola are the same distance from that red line as the points on the left-hand side of the parabola. Does that make sense? So if this point right here is 1 unit away from the axis of symmetry, this point on the opposite side is also 1 unit away from the axis of symmetry. All the points are equal distance from that axis. Everyone got that? The axis of symmetry is given by this formula right here. If you can't see that really well, I'll write it up here. X equals the opposite of b over 2a. That's my formula for my axis of symmetry. That's negative b, so it's just telling me to take the opposite sign of my b value. We get my a and b value from my equation. A value is the number in front of x squared. The b value is the number in front of x. So I plug those values in, and that gives me my axis of symmetry. So my axis of symmetry is x equals some number. What kind of a line is that? X equals some number. It does go on for infinity. But is it a vertical line, a horizontal line? Based on my figures right here, these red lines.
Is it on the X? Is it the X?
Horizontal. No, vertical.
They're vertical lines, right? So, remember, vertical lines take on the form x equals some number. So my axis of symmetry will just be a vertical line.
Can you even see what that is after the F right there?
Where?
After the F in the parentheses?
I'm going to write that bigger also for you guys here in a second. So, that's my axis of symmetry. My axis of symmetry is also my x value for my vertex. Can anyone tell me what a vertex is? It is a point.
That runs up and down. No.
Not necessarily.
Is it like at a point of two in an intersection or whatever?
Yeah, so for absolute value, it's that point where the two lines meet to form that corner, right? But for a parabola, it's just either the highest most point or the lowest most point. We call them maximums and minimums. If it's the highest point, it's a maximum. If it's the lowest point, it's a minimum. Does that make sense? It's also where the parabola changes direction. So for this first one, it's going down, 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 down. It hits the vertex and starts going up, 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 up. Over here on the right, it's going up, 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 up. Hits the vertex and it goes down, 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 down. It's where it changes its direction. Does everyone see that? So in order to graph my quadratic equations, I first want to find my axis of symmetry using this formula. I also want to find my vertex. My vertex is the point opposite of B over 2A. That's my x value. That's my axis of symmetry also. My y value is f of opposite of B over 2A. That's what you couldn't see, EJ. This is my vertex. The x value is the opposite of B over 2A. And then my y value is f of the opposite of B over 2A. And I'll kind of explain that in a little bit when we're doing our example. So I want to find my axis of symmetry. I want to find my vertex. And then I want to find my y-intercept. What's a y-intercept? It's where it crosses my y-axis. So wherever the graph crosses my y-axis, I want to find that as well. It says the y-intercept is c. It's my c value, my constant from my function. So the point 0, c is my y-intercept. Everyone see that? Using those three things, I can graph my parabola. Any questions before I move on to the example? Can I go ahead and move on, or are we still writing? Okay, so let's graph f of x equals 3x squared minus 6x plus 1. Label the vertex and axis of symmetry. So we're first going to find all the things we need to graph it. So we're going to find our axis of symmetry. We're going to find our vertex. We're going to find our y-intercept. And then I'm going to come over here and graph it on this graph for us. Everyone got it? So let's first identify our A, B, and C values. Someone raise your hand and tell me what the A value would be in this case.
3x.
Not 3x squared. What's the number in front of x squared? 3. So my A value is just 3. So what would that make my B value?
-6.
-6. And then my C value? 1. Everyone see where we're getting A, B, and C from? A is just the number in front of x squared. B is just the number in front of x. C is my constant. Questions there? Okay, let's find our axis of symmetry using our formula. X equals the opposite of B over 2A. What would be the opposite of my B value? Negative 6. 6. What's my A value? 3. I just plugged A and B into that formula. Does everyone see that? Okay, what's 2 times 3? So I get 6 over 6, which equals 1. So my axis of symmetry is x equals 1. Questions how I got my axis of symmetry. That's my axis of symmetry, but it's also my x value on my vertex, correct? If we go back and look at this slide, my vertex is the opposite of b over 2a, comma, f of the opposite of b over 2a. So that's my axis of symmetry and my x value for my vertex. Is everyone good with that? And now I need to find my y value. How do I find my y value? Yeah? Remember, here's our ordered pair for our vertex. My y value is f of the opposite of b over 2a. So how would I find my y value?
We just plug it back in.
Do what?
We just plug it back in the top one.
Plug what back into where?
Like the x into 3x to the original equation.
Very good. So I got the opposite of b over 2a to be 1, correct? So now my y value is just f of 1. Right? So I'm just plugging 1 into my function wherever I see x. So I'm doing f of 1 equals 3 times 1 squared minus 6 times 1 plus 1. And now I'm just using my order of operations to work that down. What's 1 squared? So I get 3 times 1. What's negative 6 times 1? And I still have my plus 1 on the end. Everyone with me so far? Okay, what's 3 times 1? 3. What's 3 minus 6? Negative 3. What's negative 3 plus 1? Negative 2. So what's my y value for my vertex? Negative 2. So my vertex is 1, comma, negative 2. Everyone good with that? What's my y-intercept? My y-intercept is the ordered pair 0, comma, c. And we said our c value was 1, so it's just 0, comma, 1. Any questions there? Is everyone okay with where we got all of those things? Not too bad? Now I need to graph it. I'm going to graph my axis of symmetry. I'm going to graph my vertex. I'm going to graph my y-intercept. And then I'm going to show you a little trick. Okay? So we said x equals 1. Vertex is 1, negative 2. Y-intercept is 0, 1. Correct? So I'm going to graph my axis of symmetry first. I'm just going to use a dotted line to represent it. It's a vertical line going through 1 on the x-axis. There's my axis of symmetry. Now I'm going to graph 1, comma, negative 2, my vertex. So I'm going right 1, down 2. There's my vertex. Everyone good with that? And then my y-intercept is 0, 1. So I'm graphing that ordered pair as well. Right there. Questions about that? Does that look like a parabola? No, it does not. How do you think I can get the other points to graph my parabola, though? Because that's just half of a parabola. That's just this left half, correct? Well, what is the axis of symmetry telling me I can do?
Match it. Well, don't you just count the line of symmetry and then however many points you went, you go the opposite way?
Yep. So how many units is this point away from the axis of symmetry? 1. So I can go to the opposite side of the axis of symmetry and put a point 1 unit away from it. Does everyone see that? It just mirrors it. So there's my right half of the parabola. There. Everyone see that? Any questions there? That's why we want the axis of symmetry. That way I can know which line I need to reflect it over. Questions there? All right. Let's move on to solving quadratic equations now that we know how to graph quadratic equations. Let's solve quadratic equations by graphing. So to solve by graphing, I want to graph my quadratic equation, and then I want to find the x-intercepts of the related function. So I graph my parabola. Wherever it crosses the x-axis, that's my solution. Everyone got it? We good? Ready for an example? So I want to solve each equation by graphing. I have x squared minus x minus 6 equals 0. So I'm just going to graph y equals x squared minus x minus 6. So what's my a value? 1. It's my number in front of my x squared. What's my b value? Not 1.
6.
No? Negative 1. It's the number in front of x. And then what's my c value? Negative 6. Everyone good identifying A, B, and C? Okay. Now let's find our axis of symmetry. Opposite of B over 2A. What's the opposite of my B value? 1. What's my A value? 1. So x equals what? 1/2. Good old fraction. There's my axis of symmetry. Everyone good finding the axis of symmetry? It's also my x value for my vertex. Or we could use 0.5 if you wanted. Nope. There we go. 0.5. Now I need to find my y value. How do I find the y value? Plug in my x that I got, my 1/2. So y equals 1/2 squared minus 1/2 minus 6. And now I'm just using my order of operations. What's 1/2 squared? Huh? Not 1.
It's not.
Nope. That's 1/2 plus 1/2. What's 1/2 times 1/2?
2.
No. What? No. Okay, 1/2 times 1/2. What's 1 times 1?
1.
What's 2 times 2?
4.
So what's 1/2 squared? 1/4. Very good. Any questions so far? What's 1/4 minus 1/2? Positive or negative? negative 1/2. Let's see why. Remember, in order to add or subtract fractions, you need a common denominator. So it would be 1/2 written as a fraction with 4 in the denominator. 2/4. So what's 1/4 minus 2/4? Actually, it's not negative 1/2. Sorry. What is it? Negative 1/4. My apologies. So now I get negative 1/4 minus 6. All right. We love fractions, don't we? So now I've got to get 6 to have a denominator of 4. What would the numerator be? 24. So everyone's seeing how we're getting that. Now it's negative 1/4 minus 24/4. Negative 25/4. Which comes out to be about negative 6.25. So there's my vertex. Questions how I got my vertex? We're good so far. And what's the last thing I need?
Y-intercept.
Y-intercept. What's my y-intercept?
Negative 6.
0, negative 6. Sorry, I'm writing it sideways. I just ran out of room. Y-intercept equals 0, comma, negative 6. So here's my vertex. Here's my axis of symmetry. Here's my y-intercept. Questions how I found those three things? Now I need to graph them. So we have 0.5, negative 6.25, x equals 1/2, and my y-intercept is 0, negative 6. So I'm graphing these three things. So let's graph my axis of symmetry. It's going to be about halfway between 0 and 1. So it'll be just going down right here. Questions how I got that? Now I'm going to graph my vertex. 0.5, negative 6.25. So I'm going to go right half and down 6.25. So my point would be about right in there. There's my vertex. Everyone see that? And now I need to do my y-axis, my y-intercept. 0, negative 6. It's going to be that point right there. How do I get another point for my parabola? Use your axis of symmetry. So we're half a unit away from my y-intercept to the axis of symmetry, correct? So I'm going to go another half unit over here. Actually, not right there. It'd be right there. There's my other point. Now I need to draw my parabola. There's my parabola. Any questions how I'm getting my parabola? Now, based on this slide over here, how do I solve by graphing? Yep, so I've graphed my parabola. Now I've got to find my x-intercepts, wherever it crosses the x-axis. Where does it cross my x-axis? I think I hear people saying it. 3, right? Where else? -2. It's crossing my x-axis at 3 and -2. So I know x equals -2. X equals 3. Questions there? I know it seems like a lot of work, but once you get working on it pretty quick, I've been going kind of slow just to make sure y'all are getting it as we go. But once you start plugging and chugging, it can go pretty quick. Plugging and chugging. You ever heard of that? Plugging a value in and chugging through the math. Questions on that one? All right, that's where we're going to stop for today. That's where we ended with third hour. So I'm going to stop there. No homework tonight. You're welcome. We didn't get through all the notes. We'll finish the notes tomorrow, and we'll get an assignment over what we just learned. Everyone got it?